this video about circles, we are going to be talking about central and inscribed angles. Recall that a central angle is an angle in the circle with the endpoints located on the circle's circumference, and the vertex is at the center of the circle. So the endpoints would be point A and C, and the vertex is at point O, and so the central angle would be angle AOC. Previously, we learned how to find the length of the arc AC. The arc AC is from here to here. And all you need to find the length of the arc is the central angle, or the portion of the circle out of 360 degrees, and the radius. The arc length is like you would peel off a part of the circumference and lay it down flat and measure it with a ruler. That is what arc length is. But there are actually two ways we can measure arcs. One is by their length, and the other is by their angle measure from the center of the circle. As seen in the circle below, when I use a protractor to measure the central angle, angle AOC, what do you notice about the measure of arc AC? Hopefully you notice that the measure of the central angle and the arc is the same. And using a protractor, I measure that to be 67 degrees. And so what that means is that the central angle is 67 degrees, and the arc in between the central angle is also 67 degrees. And so that would be the measurement of arc AC. So in general, the degree measure of an arc is equal to the measure of a central angle that intercepts that arc. Intercepts means that the central angle and the arc has to have the same endpoints. So let's see if you got it. Find the measure of the arc UV. And the central angle to arc UV would be angle UAV. And that measure is 126. And so since the central angle has to be the same as the arc UV would be also 126. The converse is also true. If we knew that the arc TU was 54 degrees, what would be the measure of angle TAU? And since they have to be the same, angle TAU would be 54 degrees. So this angle right here would be 54 degrees. Now let's move on to something that is new, a new vocabulary word, an inscribed angle. Inscribed angles, it is an angle formed by two chords in a circle which have a common endpoint. This common endpoint forms the vertex of the inscribed angle. So they have the chord, the inscribed angle is formed by the chords, the line segment AB and the line segment BC. A chord is a line segment that intersects the circle at 2 points, and so those two chords meet at point B, and so that forms our inscribed angle. So the inscribed angle would be angle ABC. So let's go back to our previous circle where we found the central angle to be angle AOC and the arc AC to be 67 degrees. And if we make an inscribed angle with the same endpoints and the common vertex B, so if we form that inscribed angle, angle ABC, let's find the measure of angle ABC. So I'm using my protractor to find this angle right here. And when I do that, I find the measurement to be 33.5 degrees. So what do you notice? That the angle measure was cut in half. So in general, the degree measure of an inscribed angle is half of the measure of an arc that intercepts that arc. So the inscribed angle and the arc has to have the same endpoints. So let's try one. Here we're given the arc to be 62 degrees. So what would be the inscribed angle? Angle YZX. Remember, it is half the arc. So we take the arc measurement and divide it by 2 to get angle YZX to be 31 degrees. How about we go the other direction? What is the measure of arc QR? And we are given the inscribed angle QSR to be 75 degrees. Since the inscribed angle is half of this arc, to go from the inscribed angle to the arc, we would double the inscribed angle measurement. So the arc QR from here to here would be 75 times 2, which is equal to 150 degrees.